Hello, everyone. For this session of 90 Days of DevOps for 2024, we're going to look at enhancing Kubernetes security, visibility, and networking control logic using Cilium. Little bit of a mouthful of a title. I know I was having a laugh with Michael Cade when I submitted this session, but essentially what I want to really dive into is the powerful features that Cilium brings, not only to networking, but to security and observability of a whole Kubernetes platform as well. My name's Dean Lewis. I'm a technical product marketing engineer at Icevalent. You can find me on Twitter at Saint DLE or also on LinkedIn. So first and foremost, I'm here to talk in this session about Cilium, which is an open source project that was donated to the CNCF and graduated last year. And Cilium is built upon the fundamentals of something called the extended Berkeley packet filter. I'm going to dive a little bit into that as well. Where does Icevalent fit into this? Well, we're the company behind Cilium. The creators are based here in the company Icevalent. And we also provide Icevalent Enterprise for Cilium that layers on top of that open source component as well. So what is this technology called eBPF? I'm sure by now you've actually probably heard about it in the cloud native community as well. In many years ago when I was doing these slides, we'd have to spend quite a bit of time diving into this, but now kind of that buzzword, I think, is a little bit more out there. Very, very simple level. It makes the Linux kernel programmable in a secure and efficient way. What this actually allows us to do is gives us a method to interrogate and interact with the Linux kernel in a secure ring-fenced manner to make sure that we don't cause problems. And essentially, for those of you like myself that are not kernel developers at all, it's a little bit like what JavaScript is to the browser, eBPF is to the Linux kernel. It's a way to enhance that underlying structure as well. And don't worry, in this session, we don't need to know any code like this at all either. In terms of how does the eBPF work, so you can run eBPF programs on events. So what that means is at the kernel level, we can focus on attachment points and run programs to pull data. So for observability point of view, see those events, manipulate those events or control an outcome based on those events as well. So when a process runs from the operating system down into the kernel level, we can read what's happening at that process level. We can read what's going on at a storage level, and we can see that even at that IO read right down to the underlying storage. At networking level, which is typically where Cilium is going to come in, we can see things like the connect events coming from a process. We can then look at things like the socket level, a TCP over IP level, the network device level, so right down into layer 2, and then sending that packet on the wire out of that physical NIC to the network as well. And these are some of the attachment points that we can hook into at the kernel level. So let's more focus on why we're here with this session today. What is Cilium? So Cilium covers three main areas from a cloud native point of view. So the first one is what we're most known for, which is networking and load balancing. So we are a Kubernetes contained network interface. We provide connectivity for Kubernetes service. We provide multi-cluster connectivity and also egress gateway services to the rest of the network as well. And we also do things like routing and load balancing and egress and features as well on top of that. So from a routing point of view, we can use BGP to advertise to the network what's going on inside of the Cilium environment, so you can contact the pods and containers. From a load balancing point of view, like kind of any other load balancing service you expect from Kubernetes, we could do that inside of Cilium rather than having to use a third-party provider service. And from an ingress point of view as well, if you want to publish your applications and make them available on the network and then have some level of control at a layer 7 point of view as well. From a network security point of view, we implement and enhance on top of the Kubernetes network policies So network policies and Kubernetes, if any of you used them before, they are good, but they are very limited. They sit at the layer 3 level. There's only certain combinations of those policies you put in place. With Cilium, because we have such rich data and we can see everything going on the kernel, we can see even layer 7 transactions along that network path. We can even do layer 7 base network rules as well. So I can actually say nothing connections to my HTTP service can only go to the FQDN /login / maybe logout / maybe products page, but nothing on the outside network can get to maybe internal IP addresses, internal API calls as well. So maybe on my website, I actually have something which is /internal for those internal services inside of the cloud native layer to communicate with, but on the external layer, I don't want human users accessing that as well. How do we do that? So everything that happens inside of Cilium is identity based. So because we see the underlying data path of everything gets its own unique identity, and that's how we can do all these really cool fancy features on top. We can offer one of the most question thing which that comes up as well around encryption. So encryption at a node level, traffic moving between nodes within inside of your platform. And then finally, the area that I focus on most, which is the observability point of view. So if we can see everything going on at the data path level, we can also then understand the layer 7 point of view. We can create metrics. We can give you flow visibility, very similar to like Wireshark on a network, but for cloud native. And we can also figure out things like service dependency mappings as well, which is really important thinking about troubleshooting and those configuring those network policy rules as well going forward. I'm going to keep these slides as quick and light as possible because rather than talk to you to death with slides, I'm going to show you some of this in something called our Discovery Labs going forward, and you as well are hopefully going to get hands-on with me at the same time. Just showing you kind of an overview of Cilium as a whole. So we kind of work across a number of platforms there. So whether that's bring your own Kubernetes, you build it yourself, run it yourself, manage yourself, those managed Kubernetes offerings from public cloud providers, from those more private cloud providers, from those services such as Red Hat OpenShift, from Alibaba Cloud, Azure AKS, AWS EKS, for example, as well. We at networking level have a number of features available. I'm not going to call absolutely all of these out. We have Cilium and the Hubble component, which gives us all of that observability data as well. And then those service mesh features that I talked about before as well. So things like ingress, authentication of services, traffic management of services as well. And we were even starting to see the implementation of things like Gateway API, which is the next iteration of Kubernetes ingress as well. So we're taking that new modern specification and implementing it straight away in Cilium. So yeah, who's using Cilium out in the wild? So what's really great about us using an open source technology is all this information's available. So we have open source users out there in the wild. They've added themselves to the list. They've contributed to Cilium itself directly, potentially, or even they've just wrote a blog post or recorded a video to talk about their use cases as well. As I mentioned, it is a CNCF graduated project now as well. I think we're the first CNI to do that with. Isovalent Enterprise, so how does that help you? So of course, there's an enterprise offering that layers on top of that. And if you think about it from more of a, what are you going to get depending on which team you work in as well? So not only are you going to get all the great features of the open source product, you're going to get some enterprise features on top of that as well, baked in with enterprise support and enterprise guidance with the roadmap of what's happening with Cilium and how to kind of architecture that and run that to best practice inside your environment as well, coming from Isovalent because we're obviously the creators of Cilium. So you can kind of understand our level of expertise from that point of view as well. Okay, end of the slides almost. So hands-on labs, this is the fun part. So I'm going to be taking you through today. So first and foremost, I think maybe my animations broke there a little bit. Which EB are you? So EB is our mascot. We have created a lot of labs from Isovalent, and that means we've also created a number of pathways for you to go through so you can figure out which are the right labs for you, because we always find it's better to get hands-on with these types of things. So you can just go to our isovalent.com webpage and you can go to labs and then you can choose to explore Cilium your own way. So when we click on the platform ops, you see there's a number of the labs that we've aligned to that as well. For those of you that just want to get stuck in and choose the lab that is meaningful to yourself, you can also click to view all of the labs as well. and we've got a number of labs that are available. In this session, I'm going to go through 3 labs. So we've created these discovery labs for the platform engineer, for the cloud native network engineer, and for the SecOps engineer that take you through a number of the features out of the box. You get straight away hands-on with them. We actually used these at KubeCon and we had some fantastic feedback from them. So in the platform engineering lab, you can go directly to this link here, or again, you can do it for all of these. Just scroll down our labs page, you'll see all 3 discovery labs there. We're going to cover observability, ingress and gateway API, performance monitoring, integration with Grafana at platform engineer level. For cloud network engineer level, we're going to look at dual stack IP IPv6 support, BGP, load balancing, and address pool management, layer 2 service announcement. So if you don't use something like BGP network, but you just more on flat network, layer 2 announcements out to the world as well, and egress gateway and a couple of other areas. And then finally, the SecOps engineer as well, which is one of the areas I think is the most interesting in terms of the additional capabilities that you can see at CNI level. So network observability, network policies, transparent encryption, mutual authentication, runtime security visibility and enforcement using TechCom, which is a sub-project as part of Cilium inside of the CNCF as well. And one of the great things about each of these, if you do these 3 labs and follow along or do them in your own time as well, when you're watching this video, you will get a badge like you see here. And this will be issued by credly.com as well. So if you've used other industry certifications in the past, you've probably got a credly.com badge as well that goes along with those certifications. You'll get one from Icevalent for running through our lab. Okay, so let's dive into the first lab itself. So again, you can go to our labs page and click on one of these. Okay, so we're going to walk through the Discovery Platform Engineer lab up front. For those of you that have never taken an Icevalent lab before, really recommend it. We use a system called Instruct, which is used by a couple of the other cloud native players out there as well. Each kind of section will have its own heading like this, and you can kind of slide through it a little bit like slides, and that's going to describe what you're going to do in the labs. So as mentioned on the slides, we're going to cover things in this lab like ingress controller, gateway API, and then how to visualize that traffic from the platform itself with no additional instrumentation, because it's all built in from Cilium, which is really great. A little bit more of an explanation there about Kubernetes workload traffic itself, and I'll talk you through that as we go through the pieces. About troubleshooting with Hubble and using the open source product Grafana, which is backed by Prometheus as a data store for all of those metrics. We find that's really popular with customers and users out there in the cloud native space. Great thing about this, I think I already mentioned it, you get a badge that's produced by Credly, which is where a lot of the vendor-based learning and certifications come from for badges as well. Just make sure you sign up with your correct email address that's attached to a Credly account already. And if it isn't, you'll get an email from Credly asking you to sign up to an account so you can have that online digital badge. And if you ever find Icevalent at an in-person event, go and speak to the members there as well. And we may have some physical stickers for you as well, which represent the same badges. You'll see this video, which introduces you just to the Instruct platform again. If you've never used it before, worth taking just a couple of minutes to watch that as well. But I'm sure by the end of watching this recording, you'll probably understand how Instruct works anyway. Once the lab's ready, you'll get this little flashing green start button, and we'll dive straight into that for today. If you ever run one of the Instruct labs from ourselves previously, you will find that you get a restore progress. So I can go back to where I was previously, but we're not going to do that today. I'm going to run through it from scratch. So if you're a platform engineer, you may actually be responsible for setting up the Kubernetes CNI in a Kubernetes environment, or you may not. It depends. It's different for every company. We do have labs available that take you through how to get started with Cilium and install it and check its health and so forth as well. The idea with these discovery labs is we want to drop you into a working environment with the features that are already kind of in play already, so you can kind of just see how they work and get a feel for it rather than having to kind of go through laborious setup commands and kind of deep diving into the tech straight away. So that's what we're going to do today. So we've basically got a demo Kubernetes environment set up. See here, it's got 3 nodes, and we've also installed Cilium in the background. So that's already set up and configured for us. And then there's a number of those components that are configured as well. Oh, so I've just exited that. So let me just refresh that terminal to create a new one. There we go. So we've checked the Cilium status. Throughout this demo, we are going to use Star Wars as the as kind of like the basis for the storyline that we go through. But don't worry, you don't have to be a Star Wars fan to kind of understand everything and see what's going on from that point of view. So first and foremost, we have our demo application deployed. It's deployed to an namespace called Ender. There's a Death Star with a single replica. There's a Kubernetes service that allows us access to the Death Star pod and pods in the future as we go through this. And then there's a TIE fighter and an X-Wing pod as well. And then we use that to communicate back and forth between things for testing access. So we can see that these are already deployed and available. And then we can visualize that traffic using Hubble UI. So Hubble is a component which lives alongside Cilium. You can enable it out of the box part of the configuration values, and that includes either just the CLI basis where you can connect to it over a CLI, or whether you connect to it using the Hubble UI as well. So that's an additional component that you can enable. So I click on the Hubble UI tab, and then we're going to go to the end on namespace. We can see straight away this service map being automatically generated for us and the network flows below here as well. And these are all the communications going in and out of that namespace. And then we can see whether traffic's allowed or dropped. And we're also getting layer 7 data as well. And that's coming from Cilium itself, proxying the layer, the HTTP traffic through an envoy process as well. So there's kind of a lot going on straight away for you to dive into. The main thing here is that not only at CNI level are we giving you network connectivity between pods and external to the networks, we're also giving you enhanced data analytics essentially from those flows of data as well. So you've got a way to actually see what's coming to what. You've then got abilities to match that to all of its identity and metadata from Kubernetes. And then we can even go further. So for example, if we're using a layer 7 level here, we've got HTTP traffic going on as well. We can see exactly what's going on from that point of view. We're also doing DNS resolution. So when we make calls out to an external entity, for example, not just inside of the cluster, we can then also see things like the FQDN of those external entities. So here we can see we're going to swappy.dev and disney.com as well. And if we look very closely, we can actually see that a number of those requests are being blocked, highlighted by that red line there as well. And I could even just show dropped events inside of my environment if I wanted to filter all of that. I can also filter on the top here. You'll notice going through our labs, we've also signposted you to other labs that take you deeper into these features. This is more where you'll kind of configure and set stuff up in the background as well. So let's go down. So in the X-Wing box, we kind of already done this, but we show flows involving the X-Wing identity. So we can see here now that we've got the X-Wing, we can see a little bit more of that Kubernetes metadata labels available. And we can see where the traffic's going. And we can see at the moment, essentially the X-Wing is being blocked from going to anything on our network, and it's dropped because of policy that's been put in place as well. And if I go back, so if I do kubectl get CMP, then Ender, we can see there that we've got a policy which would particularly block that as well. So essentially we've got a DNS policy that allows us to talk to kubedns for resolution, but we don't have any other policy which then kind of allows that additional traffic, which is why it's been blocked. It's an implicit delay. So any of you that have used kind of network firewalls before as well, then you'll kind of be familiar with that kind of type of logic, where if it's not expressly permitted, then the traffic's not allowed. We don't go into network policies in depth here, but again, we've got yet another lab that takes you through all of that. The main thing here is, again, not only is this CNI offering you the connectivity point of view, it also offers you those security layers as well. That's baked in as a platform. So as a platform owner, you're going to have access to this to offer to your end users. And then finally, we've got the layer 7 capabilities. So if I click here on the Death Star, and I just zoom in a little bit, We can also see here, because we're getting that layer 7 information on, can we tell it's HTTP traffic? We can also see the URL request that's been made and also the HTTP method. So we see whether it's a get, a post, a delete, and so forth as well. And then we can actually create network policies based on that layer 7 information as well. So I can actually create one that says only allowed layer 7 HTTP access to this very particular URL and query path. And even the method that's allowed on there. And then, for example, if someone comes along, just does /v1 as a lookup, see what's there and browse around it, they've denied that as well. And then we can see information here. And then finally, kind of in our environment, because we've not got too much going on, it's quite fast, we can even see we're getting latency information there as well. So how long does it take for that request to be completed from the TCP protocol? So let's move on to the next challenge. And here what we're actually going to look at is how do we, when we deploy an application into the network, how do we actually access all of that? Because at the moment, we're only looking at traffic that's internal to the cluster. So I'm going to move on to that. So essentially, as part of the storyline, Darth Vader would like to expose the Death Star externally so it can be accessed by the world. And there's a number of ways to do that inside of a Kubernetes environment. So we might use load balancing services. We might use what's called Kubernetes ingress, which is quite well known. Kubernetes ingress is a little bit like your web application firewalls in a way. But depending on what's providing the ingress services and which vendor you want to use or solution, you get different features with that. Cilium offers that as part of Kubernetes out of the box as well, so you don't need to bring in another external service from that point of view. And then finally, we'll look at Gateway API. So Gateway API is kind of like the version 2 of Kubernetes ingress. It's kind of looking again at kind of that role and ownership responsibility to you as the platform owner, offering the ability to have ingress services versus the configuration of those actual services for each individual application going forward. So let's start as part of the lab. Okay, so there's kind of a lot of information for us to read there, but essentially what we're talking about up front is how would we expose a application service from the cluster externally to the world. If you're using something like a cloud provider service, so Azure, Amazon, Google, obviously is the big three, they will sometimes out of the box kind of offer you an integration that gives you like a cloud-based load balance service straight away. So you could just do expose this application, it grabs a public IP address, it puts it through their own internal services, and then you've got access. Obviously, that's using kind of an external component that they've integrated with their Kubernetes stack and offering to do that. And there's quite a lot of kind of thoughts, considerations that you need around that. When you're internal in your own data center or even your home lab, you don't have those types of access. So that's where you've got to bring another solution into the mix to kind of offer you that. Or if you are using Cilium, as you're going to see today, that's kind of available out of the box as well. Just kind of depends on what level of features that you want and how you're going to consume that as well. So in this lab, we've got the ability, or rather with Cilium, we've got the ability to either announce services over layer 2, which is using ART requests, or we can do it using the BGP protocol, which then becomes layer 3. So BGP allows us to route out to the network. Of course, if you're using BGP, you need a router on the rec network that can communicate with that and then advertise those routes out and do the routing for you as well. Since in this lab we don't have BGP peering in place, we've used ARP and we're letting the host machine learn how to access the service using layer 2. So we're going to check the services first. We're going to look at the Death Star service. We can see here this is its internal IP address, and externally, essentially what we've done is we know what the external network is that each node is connected to. It's this 172.18 network, and we have an IPAM in the background that's used by the Kubernetes environment and Cilium to pick from when we create load balance services, and it assigns that as well. So now what this means is that this address is now basically hosted on every node connected through its Ethernet port onto the network. And if I'm on the same layer 2 network as that, I can reach it. And now what we can do is I can access this from my local machine where I am into my Kubernetes environment by running this curl command. And we can see here that we get a number of details back from that particular address. If I go to the Hubble UI, because again, we're also interested in terms of how we visualize all this, straight away I can see that's something from the outside using a world identity because we're not sure where it came from. We just know it's outside of the cluster. Access the Death Star as well. If I click on this, we can see it then spans down. We've got one flow through to the Death Star. So next, we want a little bit more control. So at the moment, we're accessing this over HTTP, but Darth Vader's not satisfied with that because it's not very secure. So what we'd like to do is offer TLS termination using HTTPS, but we don't want to rewrite the application to handle that. We don't want to have to go off and change the Death Star as well. So what we've done is we're now using the ingress features. So this is kind of the more web application firewall based type functionality that you're used to. Again, it's Kubernetes constructs that we're using to do that, and Cilium's been enabled as an ingress controller in the background. So first and foremost, if we look at that ingress setting, we can see here that we've got a class which is telling us to use Cilium, and then essentially we're just setting up a role. So we're saying that if anything hits this TLS host, so comes in on this name here, we're to use this secret name, which essentially tells it where the certificate is for authentication for that TLS. And then basically we want to send it to a HTTP request to the service of Death Star using this path on that port. Really, really simple. So basically, if something is requested on deathstar.cilium.rocks, send it to this service, and then essentially the service in the background then tells Kubernetes where the pods are as well. So let's just clear that out a little bit. So now let's try this. We're going to use a curl command. Now I'm not going to, because this is all local, I could change my etc host file to handle this, but I'm not going to. I can actually just modify that as part of the curl command, tell it where to resolve to. So the other thing that we have here on this ingress is we're actually accessing it through a slightly different IP address because this ingress essentially is a single point of call, a different load balance entity to actually get access to that as well. So not the same as earlier. And again, we can see that we get the same information back from our Death Star. So we'll clear that. Now, again, what I'm going to do is go to that Hubble UI tab. And now here we can see that this has come through the ingress identity into my network as well. And because it's going through the ingress, we can also once again see the layer 7 information. We can even see that packet there, but it was a get command. Again, there's kind of no round trip time in there. It was like 0 milliseconds, which is great. And it's kind of really simple. Ingress is kind of really good, and it's used quite heavily in Kubernetes environments today, but there are quite a few limitations with it. So, for example, who configures things like the load balancing service that sit behind it, who configures these ingress configurations as well, because inside of that ingress configuration, you've got parts of like the certificates that are used, as well as the actual pushing that route back to there. As a platform owner, that can kind of come like between figuring out who managed that specification or artifact, and it's actually you and the application owner. So what do we do going forward? Well, this is where Kubernetes Gateway API comes into it. So essentially, Kubernetes Gateway API is like the version 2 of Ingress. And what it allows you to do is create something called a gateway object, which basically is the capability inside of the platform itself. And then you can create things called HTTP routes or TLS routes, for example. And those are the configurations that then basically say, I want to set up this access to these applications using these features as well. And that's typically what your application owners are going to be using. So as a platform owner, you don't have to think about that as well. Following along with the storyline, so the first Death Star's exploded. Darth Vader's not happy about this. He's asked for a redesign of the Death Star. But before we publish this, we need to check that this works in kind of an A and B canary type testing. So we want to kind of think about how we can route traffic between two versions of our Death Stars so that we can check everything works before we release the new Death Star out into the world as well. So with Gateway API, this allows us through the HTTP route to set things like weights and balancing to those different services as well. So first and foremost, I'm going to look at this TLS gateway. So as platform one, this is what you would be configuring. And as before, we can see that we've got a different address for this because of the way that we've set it up and that we can access everything through. And then if we look at the actual specification of this, You can say it's kind of the same as what we looked at before. So essentially, we're using the same host name of deathstar.cilium.rocks. We're going to go to use this certificate for that endpoint. We're only accessing it on port 443. The protocol is only ever going to be HTTPS. And where are we allowing the routes to access it from as well? So this is going basically to the same namespace that it's being deployed in, which is in the endor namespace. And again, we've got that termination mode for TLS there as well. Also notice that the gateway class name is built in again is Cilium as controller. So now we're going to deploy HTTP route. So this is going to allow us to kind of route traffic unevenly to our different services. And here, essentially, again, for this route, we're going to tell it for anything that comes in on the host name deathstar.cilium.rocks. We're using this particular gateway as well that the traffic has to come through on. And then essentially, we're going to two backends, service of a name Deathstar, and then a second service, which is called Deathstar 2 to make it easy. And we've got a weighting there as well. So we've got a weight of 1 and a weight of 99. And then essentially we just make it really easy with a path prefix of root. So now we're going to access this to make sure we can resolve it, which we can. And I'll clear that. And then we're just going to run a quick script in the background. And this basically is then going to do multiple requests up to 200 times. Then we can see roughly that differing of access between the two. Okay, so that's completed. So we're just going to run these two commands here. And there we go. We can see for Death Star original, we've got 198, sorry. And for Death Star 2, we've just got two requests, which essentially matches that 99 over 1%. And then finally, if we go back to that Hubble UI, and I come out of here, we can see that the ingress component is still used to access this, but now when I click on this, we can see for ingress that we've got two services being accessed within inside of that endor namespace as well. We can actually route services globally across multiple clusters. So Cilium has something called Cilium Service Mesh, which essentially is that bridge and connectivity between multiple Kubernetes clusters as well, especially for those distributed applications. And again, we can route and load balance traffic against them. And if that is something that you're looking at in your environments, we do have another lab to take you through that as well. So finally, for this part of the lab, we'd like to just move on to looking at how we can use Hubble, but alongside tooling like Grafana to drill down into common Kubernetes networking and application issues as well. The reason why we're using Grafana is really simple. It's one of the most popular open source visualization tools out there. So we want to ensure that as a platform owner, you can integrate with existing tool sets used by your application owners so that they don't really suffer from tool fatigue or tool sprawl as well. So what we're going to do is visualize the metrics that we can get from the kernel layer using Cilium and Hubble into Grafana dashboards as well. So follow back along with the story again. Emperor Palpatine has ordered that the Imperial feats of resource should be easily responded with those existing tools, and reporting communications of the Death Star's most important, of course. So we've got Grafana set up with a data source pointing to Prometheus, and Prometheus is scraping layer 7 metrics from the Hubble endpoint as part of the Cilium agent running inside of the Kubernetes environment. So essentially, we have a metrics agent as part of that, and if you enable it, we can then scrape that using whatever your third-party tool is from that point of view. So first and foremost, we're just going to skip this one at the moment. But essentially, the TIE fighters are unable to communicate with resources outside of the Death Star. Something started to block communication, so we're going to try and figure out why that is. So if we go to the network overview dashboard inside of Grafana, kind of here's one that we've created earlier already, and we scroll down, we can see that we've got an increasing network policies dropped by source. And here we can see that the reason is policy denied. So we know that something has been misconfigured inside of there. And it's also increased in terms of in our lab as we've been running it. I go back, yeah, so we can kind of see like an increase there as we've gone through this. Again, each lab's going to be slightly different because these are dynamic real world labs that you're accessing to do all of this in as well. So it shows that issues are reported, but probably not related to a policy change because everything looks a bit static. But we know the issue is related to communication out to outside resources. So we can't connect to the world. So we move on to the next session. Is it DNS? Because that's always our favorite things to blame whenever we think it's the network. And the great thing about with the Hubble metrics is we can actually inspect the DNS protocol, which is where a lot of this comes from today. So if we go to this tab, we should see a sharp drop in the DNS queries, which we can do here. So I can zoom in on that a little bit more. Obviously, the requests aren't massive because it's a demo environment, but you can see there's definitely a drop there as well. And we can also see that there's missing DNS responses as well. So probably got some sort of DNS resolution issue here and things starting to give us some sort of issue. Eventually, if you leave the log running long enough, you will see DNS errors start to log as well, but it takes a little bit of time for those to come through because DNS is one of those things where things will keep trying it and keep trying it, keep trying it before it comes up with an error. So how can we start to pinpoint a particular issue? We can see it's a resolution issue. Inside of Kubernetes, you may or may not know, but it uses a service called core DNS, which is how it does all its resolution inside of the environment before it then goes outside to the world. If we go back to our terminal tab, then we can look up the traffic from core DNS to see what's happening. So I've already got a command here for you. So we can see here all the traffic from core DNS going to the outside world. So we're trying to look for that external communication problem, like why aren't we able to resolve things? And straight away, we can actually see here that we're going to this address, which is 1.2.3.4 on the correct DNS port, luckily enough. But we know that 1.2.3.4 is not the correct DNS server that we should be using. So we need to fix that issue so we can edit the core DNS configuration. And then what we can see here is that the forwarder that's being used is incorrect. So if I use the wrong command there. So let's try that again. There we go. So we're going to add in 8.8.8, and then we're going to escape, and then colon, and then write and quit this file with an exclamation mark. So that now saves that. And then essentially what we need to do is restart that DNS pod to pick up the new configuration as well. It can take 30 to 60 seconds in the lab for this to work. But essentially what we should see at the end of this there is that we now start seeing requests going to 8.8.8. And you'll see here there's a couple of different pods because there's a pod that runs on each of the nodes as well. That's why I've got different pod names so that it will take a little bit of time for each one of those to be restarted. Okay, so let's look at some layer 7 metrics for accessing our application. So this is the last dashboard that I'm going to show you kind of out of the box. We can filter this by destination, workloads, source namespace, and so forth. And we can see here that we've got request volumes coming in, we've got success rates, we've got duration of those communications. We can see here that we've got an increase of requests going back up again, which is really good. And we can really break down all of this throughout the environment for individual pods as well. Now, the main thing about this HTTP information that we're generating is this all comes from Hubble and Cilium out of the box without us having to make any changes to the application. So although as a platform engineer, you probably aren't going to go into this level of information to see what's going on in an application, but you would make this available to your application teams. And again, you actually, because this is available out of the box, may actually use this yourselves to actually pinpoint what's going on in the environment when users say their application's slow or not responding or microservices having problems as well. Essentially, it's open for everyone from that point of view. Inside of the dashboards, we're creating things like P99, P95 percentiles as well. So here, basically, we're looking at 1% of requests are taking a maximum of nearly 10 milliseconds. The mean of that is about 6 milliseconds. Essentially, P50, which is 50% of that traffic, essentially is at 2.69 milliseconds, which is really good. There's a lot to really dive into there as an application owner going forward. So to summarize, in this platform engineering lab, we deployed an application workload, we configured secure ingress and gateway services for incoming traffic. We tested those features to kind of divert the traffic between an old version of the Death Star and the new version of the Death Star. We've understood the application workload communication using a service map and figuring out what the dependencies are between them, and also saw that access through those ingress gateways as well, the world type gateways. And also looked at kind of diving into HTTP metrics in that view as well, and also using the Hubble CLI tool to see the same data but in a programmatic way. And then we've kind of dived into some of those observability features that are available for Hubble, Cilium, and Grafana together to assist with Kubernetes network troubleshooting out of the box. So that's part of the platform that you get straight away. And that concludes the platform engineering lab. So we'll move on next to look at the cloud network engineering lab. Okay, so we're going to get started with the second lab, which is focused on the cloud network engineer. I'm sure some of you have been network engineers in the past, configured routers, switches, firewalls, even maybe done some physical cabling in the network as well. But when we move to the cloud or cloud-based systems, of course, there isn't as many cables for us to deal with, but there's still the same underlying software technologies to get to grips with as well. So in this lab, again, very similar to the first lab, a quick run through showing you some of the features that it's get used to. And then we have some advanced labs that you can go off where you actually get hands-on with configuring things, testing, breaking stuff and so forth as well. So we're going to be looking at BGP with Cilium. So that's how do we connect your Kubernetes environment to your existing data center. IPv6 networking. So, quick fact for you: Cilium, when it was first produced, only supported IPv6, but now supports both IPv4 and IPv6. We're going to look at load balancer IP address management. BGP announcement to the rest of the network, layer 2 announcements if we're not using BGP. So layer 2 is really good for kind of home lab type environments as well. And then also egress gateway, so we can ensure that when our applications communicate with the outside world, we know where an endpoint that they're communicating through and that we can secure on our network as well. So Cilium itself out the box supports dual stack technologies. That means that pods can speak to the rest of the network using IPv4 and IPv6. So we're going to look and dive into that as well. And then the other bit, it kind of makes up that story, is the idea of connected to Kubernetes islands. So let's use that BGP technology so that we can communicate with different clusters, different nodes and setups with our container environment, and then again advertising that to the rest of the network as well. And again, if you finish this lab, you'll get another badge that's available through the Credly website. So let's dive in. So once again, we've deployed Cilium upfront in this lab, so that's available for you out the box. And if I run this, we can see that it's all there and operating in the background, which is fantastic. So again, we're going to use some Star Wars references in this one because the Isovalent team really love their Star Wars. And essentially the idea here is that your Kubernetes cluster is ready. It's going to be located on the other side of the galaxy. And that kind of just sets the backstory as well for connecting some of these different Kubernetes clusters together. Is the idea is it's different kind of planets and systems and bases from the Star Wars world that will be connecting together. But again, if you don't follow Star Wars, don't worry about it too much. So first and foremost, Cilium allows configuring the Kubernetes networks either using an overlay network or direct routing. So an overlay network is where the traffic is encapsulated as it moves between the nodes when pods speak to one another. Direct routing is where it actually uses the normal kind of networking of the environment that your host nodes are connected to, and then they communicate over that normal network as well. There are pros and cons for using either one of those. Predominantly, you see customers using overlay networking, but we're not going to dive into that too much today. But it's definitely something to be aware of when thinking about Kubernetes environments and deployments and CNIs if you're looking to architect them as part of your job role. In this lab, we're using direct routing and the pod siders are propagated using BGP to take an existing BGP infrastructure. In our lab, we're using something called the free range routing and a virtual networking platform called Container Lab, which is really, really cool if you're looking at whole lab environments. And we can actually see how that's set up as well in this tab. We've got a nice little web interface for this as well. So we can see here we've got a router sat in the middle, and that's what we're going to be communicating to when we use BGP. And then we can see a worker nodes either side and a control plane. So these are actually our Kubernetes nodes because they're also doing part of the routing in there, as we mentioned. And we've also got this client here, which essentially is going to be our separate host node, which we're going to treat as an outpost that we need to communicate with as well going forward. So first and foremost with BGP, it would set up a peering policy with network devices such as top of the rack and advertise Kubernetes pods and CIDR ranges to there so that the rest of the data center network knows how to communicate with those applications. So if I go back to the terminal tab, we can see that policy in place by using kubectl get Cilium BGP peering policy. Quite a mouthful there to kind of remember. But we can see here that there's a peering policy available for each of those nodes because each node is going to peer with that route that's sat in the middle of that diagram. And then we can inspect that peering policy. So let's look at that for the control plane. And essentially here we've got the node that it's coming from. We've got that we're exporting the pod CIDR. So we're telling it that for the pods that run on that node through the pod CIDR address that's used inside the cluster, we need to externalize that. We've got the local ASN number, which is pertinent to BGP connectivity, and then the peer ASN, which is the router we're connecting to. A couple more details about those neighbors that we're connecting to as well. And then service selectors, with which services are we announcing to the outside world. So that's where we set up things like load balancing and so forth as well. Anything that basically has this label attached to it as metadata. So if we set up a new load balancing configuration inside of our environment for a service, but don't have that label, it will not be advertised to the rest of the network. So if we go down, I'm just going to clear. It helps if I spelt the word clear correctly, but we're just going to clear that down. And we want to see the peers that are available. So we can see here using the Cilium command, the CLI, not only do we use Cilium CLI to install with, but we also actually use it to interrogate the health and some additional options with Cilium as well. So using the BGP peers, we can see the output that's available, and we can see that essentially each session is established. That's what we'd like to see in the background. And then what we can do is we can log into our router as well to check out the peer and the connections on that side as well. So because we're using this in a lab environment, essentially our router is another software device that's running inside of a container. So if we log on to it here and we do show BGP, inside of this particular routing path, we can see each of the nodes inside our environment, and it's using IPv6 for that as well. So that's the 3 routes and 3 total paths, which is our 3 nodes in our environment, which is the control plane and the 2 worker nodes as well. As I mentioned, we do have a couple of deep dive labs available for BGP as well, and we get some fantastic feedback about that. And it shows how to set up BGP, how to troubleshoot things, how to set things like the pairing policies in place, the retry methods, authentication. We've got an advanced BGP lab as well to look at different ways to do the routing as well from that point of view. So let's just concatenate that down and let's look at the BGP, the IPv6 support. So we'll notice that all communication has to be executed over IPv6 as part of the storyline. And some ships only support IPv4, which is why we're in a dual stack mode. And essentially, how do we make this happen? Really, really simple. We basically just enable it as a config. So if we look at the configuration of Cilium, it's as simple as saying enable the IPv version that you're interested in and set that as true. And Cilium does everything else in the background for you, nice and simple. Okay, so now we're going to start to dive a little bit more into this Star Wars type demo to show the rest of the lab as well. So a remote outpost on the Batu includes a new Death Star, because the previous one had an unfortunate incident. Actually, we did that in the last lab as well, where we looked at it blowing up. This new manifest will deploy a namespace. It's going to deploy a deployment with 2 replicas, a Kubernetes service that allows us to access the Death Star either using IPv4 or IPv6. Then we're going to have a TIE fighter, A TIE fighter that uses only IPv4 in environments. That's a pod that's got IPv6 connectivity, or a pod that has IPv4 only connectivity. And then finally, the X-Wing as well, which would just be another pod. And essentially, we're going to look at those different access methods within there as well. So let's get those deployed. Okay, so that's the Death Star deployed, and then finally we can check all of the deployments here, so we can see the we're just slowly coming up for those applications as well. We might need to just run this a couple of times just to make sure that they're available. And it can take around 60 seconds for that to come up. So I've run the wrong command there, so I'll skip ahead a little bit. But that might give us enough time to see things run up. So just still taking a little bit of time for that to come up here is what we're waiting for those to become available. Okay, and now we can see all of that's come available, just a little over 60 seconds for that side of the law. And now we can verify that the Death Star pods have got both IPv4 and IPv6 addresses. So we've got two of those pods, remember, as part of that deployment. And we can see that's both those addresses there that are showing up. And then let's get one of those IP addresses to an environment variable inside of our environment. So that's the IPv6 address. And then we're going to test that we can connect to this pod via their IP address from the server client containing the network. So this is our outpost inside of our environment. And we can see that that's available. And the reason why we know that works is because we've got the BGP routing set up, we've connected to the correct ASNs, and we're advertising those IPv6 routes. So essentially what's happening here is we're using this server client here on this topology to connect to a pod that runs on one of our worker nodes, which is where our Death Star is located. And then finally, if we go down to visualize the traffic, so we're going to look at that Hubble UI, and you may remember this from the first lab that we ran through. We can basically see now inside of we're taken to the Battery namespace by default. We can see that we've got our X-Wing communication going to our Death Star, we've got the TIE Fighter and the TIE Fighter V4 as well. And if we click on the Death Star, we can see that it's port 80 HTTP traffic using TCP as well. And then to look at this a slightly different way, we can also do this inside of the terminal as well. So at the moment, whenever we use Hubble Observe, it will always try to do name resolution inside of the environment. But we can use this command here, which is the IP translation equals false, which gives us the IP addresses from the side of the environment as well. So we can see here that we're communicating on IPv6 to and from those nodes. And then if I clear this one, and then if we do it from the TIE Fighter -4, which is the pod that only has an IPv4 address, we can see here that it's communicating over IPv4 to the environment as well. Okay, so now let's think about using the routing protocols to connect to our Death Star from outside of the cluster. So load balancer IP address management is a new feature inside of Cilium that allows you to provision IP addresses for any Kubernetes load balance services. This is really handy, especially if you're using Kubernetes in a non-cloud provider environment, where the cloud provider will provision things like the load balancing services for you. You can do this inside of your own data center and give that cloud-like feel as well. Previously to Cilium 1.13, you would need to use maybe an additional tool like MetalLB to do the address allocation. But now with 1.13 and later, that is a built-in feature available for you as well. Okay, so the Death Star needs to be accessed over HTTP from the outpost station. In order for this Imperial base to be Imperial base to access the Death Star, you will need to create a Kubernetes service with the load balance to expose it, assign an IP address, and advertise that over the BGP. So remember we talked about the labels earlier on? Essentially, we're going to be using that now as well. So first and foremost, we're going to check the Death Star service. So we can see here that there's no external IP address at the moment for that Death Star, so it's not available. And we can see it's got an org label of org equals empire. I'm going to look at our LB pool that we're creating. So we can see here in this LB pool, we're going to call it Empire IP pool, and these are the side range we use on both IPv4 and IPv6. So also we can use both of them inside of the same configuration. We're going to apply that, and then we're going to ensure that it's been successfully deployed. So yep, so we can see that it's available, how many IP addresses are available, and now we should be able to see that this external IP address has now been assigned straight up as well, because it's been picked up, and we've moved from pending to assigned addresses. Now we need to advertise this to the rest of the network as well. So first and foremost, I'm going to retrieve the external IPs for the service. Just going to run 2 commands there to add them to variables, and then we're going to try and access it from the server client container. And what we're going to notice here is this actually times out, which means nothing responds on the network because we can't connect to it. And if we get the peering policy, we can see here, again, we need that label to match the announced. So now what we're going to do is label the service with the announced equals BGP, and that becomes available. And then we're going to move on to retry that service. And now we can see that it's available because we've told the service to use that label, which means now it can be advertised over the network using BGP. And then finally, one last way to look at this is we can also offer layer 2 announcements, and we're going to look at that through the IPv4 address instead. So again, we're going to see this timeout because the IPv4 address isn't announced on the network at all at the moment. We're going to apply the layer 2 policy, and we can have a quick look at that layer 2 policy as well. And essentially, we're matching the service selectors that are on there, which interfaces are being used by the pods, and then advertising it for external IP addresses and load balancer addresses. And now, if we try and access that service again, same happens. It's available. We can connect to it over the network. And now we're going to look at exploring outgoing traffic in our environment using egress gateway. So in many enterprise environments, applications that are hosted inside of Kubernetes need to communicate with workloads that are outside of the Kubernetes cluster. And these typically have constraints, security enforcements. And one of the issues with that is traditional firewalls, for example, rely on static IP addresses or a known IP address from the network that this is coming from. It can be hard to bring Kubernetes environment into your data center because of that. Because again, the traffic could exit from any known node inside of that cluster to the outside world. So using a feature such as egress gateway with Cilium out of the box gives you an ability to set up some masquerading rules that you have known exit points in your network and can understand the addresses that your application is going to communicate externally on as well. So essentially, traffic from these pods will be sourced and to the IP address of the node and will reach the external firewall with a predictable IP address, enabling the firewall to enforce the right policy inside of the pods as well. And then we can kind of see that using this diagram as well. This is what we're going to be doing in the lab. So we've got our compute nodes, we've got our pods, they come out with direct access, and they go through this egress gateway access to our remote outpost container. So first and foremost, to get us started, we've got a remote outpost, which is just another Docker container that we kind of visualize on the network inside of our home lab to kind of test its connectivity. For security reasons, the security team only wants to identify incoming traffic and only allow traffic coming from this IP address, which is the 10.0.3.42. And if we try and access that address on the TIE Fighter pod here, we can see that basically we set it up so that a message comes back and tells us we're not allowed in our environment. If we try to access it from its own range, then it's denied, and the same comes between the X-Wing pod as well. So again, access denied. We're going to skip over this section to ask us a couple of questions because I'm doing this live. And then now we're going to show a kind node in the cluster. So worker node 2, it's been configured with a label to allow it to be the egress gateway to distinguish it from other nodes. And essentially what we're looking for here is just to confirm that that label has been configured. And then it's been assigned this IP address on network 1. And then basically we'll look at that container, which represents our Kubernetes node, to see if that's true. And you can see that here. So now we're going to set up an egress gateway policy that basically says any pods that are labeled with org equals empire will try to reach the 10.0.4/24 network, and we'll leave the Kubernetes node with this label. So we can review that policy here. So we can see any traffic that goes to this destination, the pods that it originates from this label, will exit the node that is tagged with this label here, and it will be on network interface 1 on that node itself as well. So now we're going to apply this. if I just clear this up ever so slightly, and then we're going to run this access from the TIE Fighter again. And now we can see here that our source address matches our allowed IP address in our firewall rules. Whereas again, if we try the X-Wing pod to access that, it's still denied by that policy. And that's it. We kind of wrap up this particular lab focused on cloud networking, which I think is really, really important. You know, when we think about the design and the implementation of Kubernetes, especially bringing it with your existing workloads. But we've covered a couple of key features in this particular lab, which is the native support for IPv6 and that dual stack ability out of the box, using BGP to advertise services to remote hosts and your entire network and data center. The load balancer IPAM feature to allocate IP addresses to Kubernetes services, the layer 2 service announcements as well, so you can use layer 2 announcements onto your network. And then finally, the last piece, which are the egress gateway policies as well. So this wraps up the Cloud Network Engineer Lab. Okay, everyone. So we're going to dive into the final Discovery Lab, which is covering the SecOps engineering role. So looking at all things from a security lens inside of our cloud native environment running Cilium. And also we're going to use Tetragon as well, which is a open source project born out of Cilium originally as well. It sits side by side with that and offers some really cool kind of options from that point of view. In terms of some of the stuff we're going to cover, we're going to look at another Star Wars demo, and we're going to touch a little bit of some of the same information that we've seen in other labs, so I'll skip over that as well to make it shorter. But essentially, we're going to look at connectivity observability with Hubble, network policies, mutual authentication with Cilium, which is a really big one, transparent flow encryption across the Cilium platform, and then runtime observability from a security perspective using that Tetragon code as well. Kubernetes out of the box is not tailored for a security sensitive environment by any means, which is why you want to be using something like CNI, such as Cilium, that offers you those advanced network policies to provide control around that network traffic inside of your environment, as well as maybe adding Tetragon there as well to give you that runtime enforcement, which looks at the kernel level of what's happening when processes run inside of the environment. So kind of really, really key from a perspective of what you're going to do with your long-lived cloud-native clusters going forward as well, or even short-lived Kubernetes clusters. But definitely as you start to mature your cloud-native offering inside of your environment, this is something you really need to start thinking about going forward. Network policies, very similar to what we understand from firewall policies in traditional networking. They obviously define and restrict access with and without inside your cluster, and namespaces talking to one another and pods talking to one another, even if that's within the same namespace, and also then external to your environment as well. Encryption, you've got two options using Cilium, so that's IPsec or WireGuard. We're going to be using WireGuard in this particular lab, and that's going to secure the traffic between all of the nodes in that platform. And then mutual authentication ensures that both the client and the server communication exchanges verifies each other's identity, and that helps with things like man-in-the-middle attacks as well. So combining that with the cluster level node encryption then gives you a kind of more robust Kubernetes security strategy as well. Okay, so I'm going to jump straight into this lab. So first and foremost, we'll just check that Cilium is up and running, which it is. Fantastic. We're going to deploy the same application that we talked about in the last lab, which basically is our Endor set of services. So we're just going to make sure that those come up and then visualize that traffic. Okay, so visualizing that traffic, we can do that using Hubble. So we already saw that in one of the previous labs as well. Basically the same kind of views there. Got various connections to the outside world. We've also got some drop traffic going on and so forth. So we're going to dive into that in a little bit more detail. So first and foremost, if we click on the X-Wing pod here and we scale into that, we now only see the X-Wing, and we see here that all the traffic going to the Death Star is dropped because obviously Darth Vader doesn't want the X-Wing ships attacking the Death Star going forward. And if we go to the terminal, we can see that as a policy verdict of denied as well. So we can see here we've got an ingress coming in, which was allowed because it's layer 3, layer 4, and that was going to core DNS that was doing a name resolution lookup. That's why it was allowed, because policy allows that. But then there's no policy verdict here because there's no policy that applies to the traffic from X-Wing going to the Death Star. Therefore, it hits an implicit deny. Again, very simply to what we'd see in a traditional firewall on your network. If you want to dive deeper into network policies, we've got a specific badge for that. And actually, I didn't cover that at the start, but there is a badge available for this SecOps lab as well for you to get access to. Okay, so if we go back to the Hubble UI, we're going to click on the Death Star, and at the moment we can just see that traffic is coming in only on port 80. We can see it's TCP traffic. Now we know that port 80 is probably going to be HTTP traffic, but we don't see any visibility there as well. So if we go back to the terminal, really quick and easily, we can actually set up the parsing feature of HTTP by pushing that traffic through an Envoy proxy within the Cilium platform itself. So you don't need to configure anything else. It's there by default. And we'll do that by annotating this particular pod. This annotation is a legacy method, so it's available still within Cilium 1.14 and earlier today. Still available in Cilium 1.15, but from 1.15 going forward, we recommend that you configure this as part of a network policy as well. So again, depending on the version that you deploy, really worth just diving into the documentation around those features to make sure that you're using the best practice, the best method to do this going forward as well. So in later versions, you'll see that, 1.16 going forward, those documents basically say, you have a new way to do this, which is better. Now, if we go back to the Hubble UI, we're going to see here now that we can see it's HTTP traffic, so we're parsing it. And we can also see that we're going to the request landing and that it was a post against there. And we can see it showing up in these flows as well. Again, very similar to what we saw in the platform engineering lab at the start. But again, this work features crossover because from a security point of view, you also want to know this level of detail. From a mutual authentication point of view, you can also see here we've got a little lock, and that lock tells that mutual authentication is enabled for the communications of the traffic. And if we go back to the terminal, let's check that network policy to see how that was made possible. So mutual authentication has been enabled as part of the Cilium platform configuration. And then to make this to enable this for your applications, it's very simple. When you set a network policy, just add these two lines and authentication will be enabled for you going forward. We've got a deep dive lab on mutual authentication as well in terms of diving into that, and also how you can actually use something called TCP Shark, very similar to Wireshark, but for Kubernetes environments. And you can actually look into that traffic and make sure that the mutual authentication is happening as well. The last piece we wanted to look at, so again, we're still on this terminal, is WireGuard. So if we just look at the Cilium config, we can see that WireGuard has been enabled. Again, very, very simple configuration. Enable WireGuard equals true, and the cluster will do everything in the background for you. All traffic then is encrypted between pods when the traffic has to go between nodes as well. It's basically the node-to-node traffic's encrypted as well here. So we've got this as part of that config of encrypt node. And essentially, so we've got pod-to-pod encryption where the pods live on different nodes and they've got to speak across those nodes. So that traffic that's tunneled across them. And then also we've got node-to-node encryption as well. Node-to-node means any cross-node communications are encrypted between those Kubernetes nodes as well. So really, really simple. Again, we can dive into that in this particular lab here at the bottom. And that, again, we'll use TCP Shark for you to verify that traffic is encrypted and so forth as well. Okay, so next move on to my favorite part of kind of working with the Cilium platform, and that's actually working with Tetragon, because Tetragon gives you security visibility and enforcement. It's doing that at the kernel level, so we can actually see what's happening when processes run our environment. What happens, for example, if an attacker executes a command on our pod, and then it gives us the data so we can actually link that and find the resulting actions as well. So we're going to do that inside of our environment in this discovery lab. And I'm also going to show you how to find the answer for the exam question, which is just one question, and that gets you the security ops badge as well as part of this. Okay, so we're just going to dive straight in here. So, as along the storylines of Star Wars again, the Death Star has exploded. Darth Vader is not happy. So let's just double check that. So we can see here that this Death Star has restarted. Basically, it means that that's what's happened for it to run again. If we check the logs here, we're going to see that there was a panic. The Death Star exploded. Oh no. So let's see if we can figure out what happened here. So first we need to try Raj and investigate this. So I'm going to clear down there. I'm going to go to the Hubble tab and I'm going to click on the Death Star box. And now we can see that there's a new request come through and it's going to the exhaust port. And for any of you that follow the Star Wars movies, we all know that the exhaust port is the reason why the Death Star explodes. It's the one weakness. It's that open back door that lets the attackers in. So we know that a vulnerability's been hit as part of the storyline of this lab. We already knew that the exhaust port was a problem, but we've yet to fix it because there's lots of things for us to fix. And now we've suffered at the hands of the Alliance for this. So we're going to go back to the terminal. I'm going to click on this lab here so we can actually see all pods that were communicating on that particular port. So, port on that HTTP path. So we use the HTTP path filter. And here we can see that it was, in fact, the TIE fighter that was doing this. This means that it wasn't even a rebel ship that was destroying our Empire's Death Star. It was friendly fire. We can also see that in the Hubble UI as well in this lab, which is kind of show you the details on both sides. So let's dive into this even further. So now we're going to do some more forensics and root cause analysis so we can figure out why our own friendly fire was trying to connect to the exhaust port, kill it. So first we're going to find out by which node that pod caused this. So we can see here we've got the pod name as well. We're going to run this command and we can see the node that it was on was kind worker. And then we're going to run this command here. And now we're going to inspect the tetragon logs relating to any connection to that particular HTTP path as well. So I'm just going to run this command. And again, in our lab, we keep that traffic going. So you may have to wait for a couple of seconds for it to reappear, essentially going on in the background quite a few times. There we go. And we can see here that we've got that process event back, and we can see that there was a curl command, and then these were the arguments of that curl command as well. And then this the TCP traffic being passed. And then again, that's the exit code for the event as well for that process running that curl process. So we can see the process, the network connect, the network close, the process exit, the namespace in the pod, the binaries that are used, and the argument details for that. There is a security visibility lab using Tetragon, so you can deep dive into this. And then the final part that we wanted to look at here as well using Tetragon is viewing this data using JSON. So actually this is kind of a compact version of the data, but actually for your SIEM environments where you can export this JSON file, there is a whole host more details that can be pulled through for that as well. So we can see here again, very simply, the same binaries being used, the executables, any flags at the kernel level. Again, that same Kubernetes data that we talked about. We can see when this happened from a start time. We can see Kubernetes pod labels. We can see the workload name. And also as well, we can see the capabilities that that container was running with as well. So this is really useful when looking for container escape attempts where capabilities are either too permissive already, or the capabilities are being leveled up inside of your environment. And then finally, we've got to capture the flag for this where we need to edit this in the editor. And essentially, we need the binary. So I'm going to go to the editor here. And the answer is going to be this binary. And then we want the arguments as well. So I'm going to put them within these brackets. And this auto saves for us. And then now I'm going to click finish, and that's going to complete the challenge for us. It's a very, very quick run through in this lab because we've covered a lot of some of the parts of the platform that make the security parts of this available already. But we covered network observability, network policies, transparent encryption, mutual auth, runtime visibility, and enforcement using Tetragon as well. Okay, so that's really wraps up the labs that we talked through, the slide decks. There's lots of labs from isovalent.com. So again, just a quick reminder, we can go to isovalent.com. We can go to the labs tab here. You've got the learning paths that are available that take through curated views, depending on your job role or function, or you can simply just view all of the labs to go through them. And then what we've done is we have this link here, which is labs-map.isovalent.com, and that allows you to track your progress on our little island as well view. So that's kind of really cool and a little bit of gamification for you there. Want to learn more? So there is a weekly Cilium and eBPF AMA with Thomas Graf, our creator and co-founder of Cilium and the CTO at Isovalent, and some of the other community members join that as well. You can request a demo if you want to look at the enterprise side of it. So isovalent.com/request hyphen demo. And then finally, I apologize. This actually should probably say join us at KubeCon Europe as well. We will be there in April. We've obviously had North America in Chicago. Um, Thank you for if you've taken the labs at the same time as watching this, or if you're about to take the labs, be sure that you finish the labs, add any reviews. We see and use that feedback on a regular basis to enhance our labs going forward. Please share it on Twitter, follow us on social media for information about updates to the labs as well. And just really hope this was useful for everyone. So thank you very much. Have a good day.